Hello students, in the previous lecture 12th standard chemistry chapter 1 lecture 1 we had studied the distinguish between crystalline solids and amorphous solids. Chapter 1, Lecture 1, we had studied the important points of difference between crystalline solids and amorphous solids. First point was regarding definition. Second point, whether they are true solids or pseudo solids. Third point we discussed was regarding melting point and the way they melt. We had also studied in the point number 4 that crystalline solids are usually anisotropic while amorphous solids are isotropic. In the second lecture, chapter 1 solid state, we shall begin with the discussion of very important terms. They are isotropy and anisotropy. Let us understand the meaning of isotropic solids and anisotropic solids. Suppose we move through a solid in different directions, and if we find the values of physical properties, that is physical quantities, are same in all the directions within a solid, then such solids are called isotropic solids, and the phenomenon is called isotropy. And suppose the values of physical properties, physical quantities are not same in different directions within a solid, then such solids are called anisotropic solids, and the phenomenon they exhibit, they show, is called anisotropy. All amorphous solids and few crystalline solids like metals, metallic solid, are isotropic solids, and most of the crystalline solids are anisotropic solids, and the property they show is called anisotropy. Once again, the amorphous solids and few crystalline solids like metals are isotropic solids because in them values of physical properties are same in different directions, whereas in crystalline solids, if we move in different directions within the solid, we will observe values of physical properties different. Thus, crystalline solids, most of the crystalline solids are anisotropic solids. Last time, if values of physical properties, physical quantities like density, viscosity, refractive index, dielectric constant, etc. are same in all the directions, in different directions within a solid, then the solids are called isotropic solids, and this phenomenon is called isotropy. Amorphous solids and even crystalline solids like metals exhibit the property of isotropy. They are isotropic solids. But if the values of physical properties, physical quantities like density, viscosity, refractive index, dielectric constant, etc. are not same in all the directions, in different directions within a solid, then such solids are called anisotropic solids, and the phenomenon they exhibit is called anisotropy. Crystalline solids, most of the crystalline solids in fact are anisotropic solids, and they exhibit the property of anisotropy. Let us understand the reason why amorphous solids and metallic solids are isotropic solids. We know that in amorphous solids, the constituent particles are not arranged in orderly manner. Their arrangement is random. So, if we move through amorphous solids, in different directions, then we will meet on the way more or less same number of particles. As for example, if we move 5 nanometer in this direction, 5 nanometer in this direction and 5 nanometer in this direction in an amorphous solid, then more or less will be meeting on the way same number of particles, and values of these physical properties are same if number of particles per unit length is same. So, values of density, viscosity, refractive index, dielectric constant, etc. will be same in all the directions, different directions within amorphous solids. And that is the reason why amorphous solids are isotropic solids, and the phenomenon they exhibit is isotropy. If we move in different directions in crystalline solids, then number of particles per unit length will not be same in different directions. See, the number of particles are not same per unit length in all the directions in crystalline solids. So obviously values of density, viscosity, refractive index, dielectric constant, etc. will not be same in all the directions, in different directions within crystalline solids. It means that crystalline solids are anisotropic solids. The property they exhibit is called anisotropy. Thus, amorphous solids are isotropic solids and crystalline solids are anisotropic solids. Although metallic solids are crystalline solids, they are isotropic solids because they have specific textures within that make them isotropic solids. Apart from metallic solids, the other crystalline solids are anisotropic solids. Glass is an example of amorphous solid. The values of these physical quantities in glass are same in all the directions. That is the reason why we call glass an isotropic solid. Even metals are isotropic solids. Remember, isotropy has made glass, metals, etc. very important material. Because glass is isotropic, it will show same values of these physical quantities in all the directions. And that is the reason it was possible to make lenses, homogeneous lenses, with the help of glass, and these lenses were fitted into telescope right from Galilean telescope to Hubble telescope, and it was possible to explore space, universe. Had glass been not isotropic, we would not have made lenses, we would not have looked into the universe, the distant galaxies, and whatever knowledge we have regarding universe, we would not have obtained them. So thanks to isotropy exhibited by glass, we could explore universe. Thanks to isotropy exhibited by metals, that metals are malleable, ductile. We can prepare thin wires, we can prepare thin sheets out of metals. Remember, if we heat metal, then it will expand uniformly in all directions. Or if we cool metals, it will contract equally in all directions because of its isotropic nature. And that is the reason why metals do not break on hammering, on heating, on cooling. This makes metal precious. The property of isotropic makes glass, metals extremely useful. Last time, if the values of physical properties like these are same in all the directions, then solids are called isotropic solids and the phenomenon is called isotropy. And if values of physical properties like these are not same in all the directions, in different directions within a solid, then such solids are anisotropic solids. Amorphous solids are isotropic and most of the crystalline solids are anisotropic.